Assalamu alaikum, girls. For understanding how you can draw the image in the plane mirror, you have to see this video very carefully. See it and then we will start our lesson.
Good afternoon. What I would like to show you today is how to draw a ray diagram that shows the formation of a virtual image by a plane mirror. Often comes up in P1 exams at the moment. So, first thing that I would do, the easiest way I find to draw these, is to draw on the virtual image itself. This is easy because on a plane mirror, the virtual image will appear to be the same distance behind the mirror as the actual object is in front of the mirror. So you take a ruler, measure the distance, which as you can see is 3 centimeters. So the flame of the real candle is 3 centimeters from the mirror. So we would draw the flame of the virtual candle 3 centimeters from the mirror. So 3 centimeters, 3 centimeters. Then we take the bottom of the candle. You can see that that is 4.5, about 4.5 centimeters from the mirror. So that means that we must draw the bottom of the virtual candle also 4.5 centimeters from.
For drawing this image, girls, you have to remember the 4 properties of the image in the plane mirror. Number 1, the image is virtual, so it will not form on a screen. Number 2, the image will be literally the image will be literally inverted. Number 3, the image will form at equal distance and of same size. Now this image is drawn in this video, and all the images will be drawn by you also by considering these points, that the distance of the object from the mirror is equal to the distance of the image from the mirror. And this is not a pointed object, so we will discuss the pointed object image also, but first you will understand it and then we will discuss that you have to draw the equal distance perpendicular lines from the top of the object and behind the mirror also to draw the image, and from the bottom of the object and behind the mirror also. So let's continue this video.
So then simply draw our candle, our virtual candle on. You get the idea. So what we've got now is a diagram that shows our mirror, our real candle, and the virtual image. And the idea of a ray diagram is to show how that virtual image forms. And this is the way that I find the easiest. You're going to start by drawing 2 straight lines from the virtual image to the observer. And you do those 2 straight lines firstly from the top and then the bottom of the virtual image. While you're working behind the mirror, we're going to use a dotted line to represent the virtual ray of light. It isn't really a ray of light inside the mirror. This is just what your brain thinks is happening. And then once we're in front of the mirror, we can draw a proper bold line, draw an arrow on it to represent the direction that the ray of light is travelling. The ray of light is going into the person's eye. We then do the same from the bottom of the candle. So a dotted line whilst we're working inside the mirror, as it were. So it's a virtual ray of light, and then once we're on the front of the mirror, draw a proper line. Again, we'll put our arrow on to show the direction that the ray of light is travelling in. Now, we know that this isn't what has really happened. There isn't really a ray of light coming from this virtual image inside the mirror. What has actually happened is rays of light or light is being emitted by the candle, it's bouncing off the candle and is going into the mirror, it's bouncing off the mirror and into the observer's eye. So that is what we're going to draw next. Firstly, we'll draw a line to represent a ray of light coming from the top of the candle and hitting the mirror and going into the observer's eye, and that must hit the mirror at the same point as this ray of light emerges. So now what we've got is a ray of light that has come from the top of the candle, it's bounced off the mirror into the observer's eye, and if you were to draw a normal line here and measure your angle of incidence and your angle of reflection, you would find that they are equal. We can then repeat that process on the bottom from the candle. So a ray of light has bounced off the candle towards the mirror, hits the mirror, bounces off and into the observer's eye. We put an arrow on there again to represent the direction that the light ray travels. And these marks, ordinarily you would get marked for putting the virtual image in the right place, but ensuring that the arrows are representing the correct direction the travel of the ray of light, so it's coming from the real object and going into the observer's eye. You should make sure that your rays of light are bouncing off the mirror, not in front of it or behind it, and you should be drawing nice straight lines with the ruler. And there you have it, the formation of a virtual image by a plane mirror.
Okay, girls, I hope that everyone has seen the video very carefully. Now, few things about the video, that if you see this video up to here,
bounce off the candle, direction the travel of the
now
ray
here
light
the image is
from the real
complete.
object.
See it carefully, that first we must have a clear idea that on the side where the object is placed in front of the mirror, at the same side there will be an eye. In many questions in the past papers, it is asked that draw the eye. On which side you will draw the eye? On the object side, number one. Number two, for the formation of image by the rays, you have to use scale. It's very important. For drawing the straight lines, you have to use the scale. Number three, when you will draw these points, you can draw these distances in the form of dotted lines. You can see in your books the images are drawn there. They have drawn the dotted lines, and I will also show you in my presentation about it. And for getting this point of incidences, what's important? That after drawing the shape of the image by taking equal distances, you will draw the dotted lines. You always draw the dotted lines behind the mirror and straight lines in front of the mirror. And these dotted lines you will draw by the scale towards the eye. Okay? And the top and bottom line should be converged at the eye. You can see that when they are going to come towards eye, they will intersect the mirror at these 2 points. These 2 points are the point of incidences. If you draw the normal here, normal number 1 and the normal number 2, you can draw the angle of incidence and angle of reflection. Always remember, the rays coming from the object are the incident rays, and rays coming from the image are the reflected rays. When you draw the normal, you can measure the angle of incidence between the normal and the incident ray, and the angle between the reflected ray and the normal. And in some questions, it is asked that measure the angle of incidence and reflection and prove the laws of reflection from the diagram. Hope so it will be clear to you. Now we will continue with our presentation. That is, I was discussing about the image formation, and here it is. Yes. Okay. Here is our destination, that is ray diagram of pointed object. Now, in that we have taken a candle. If it is a pointed object means that by simple dot, you have to draw the image of this point. That is, for the object, you will label it as O, and you will draw an equal distance. For example, if this is 8 centimeter, you will draw the same perpendicular distance on the other side behind the mirror, and that will be image distance. And at the same distance, you will draw a point showing the image, this. And image is represented as capital I. And when you draw the rays from the image towards the eye, okay, these rays intersects at the mirror at 2 points. These points are known as point of incidences. And at the point of incidences, as I've told you in the video also, if you draw the normal, if you see this is the normal 1 and this is the normal 2, you will get angle of incidence as well as angle of reflection. Angle of incidence 2 and angle of reflection 2. Okay, so you can also measure these angles and they will be equal. Okay, so how we have drawn it now, it should be clear. You have to do a written practice of it, and it's important task for you that you have to draw these ray diagrams, including in this chapter, in your neat copies. You have to draw these ray diagrams, and I will give it as an assignment to you in this week. Okay, now if you see, this is a comparison of the ray diagrams of extended object with the pointed object. This is a ray diagram of the pointed object, and this is the ray diagram of the extended object. A straight arrow, the image is in the form of arrow. Okay, these E and H are the rays showing towards the eye. Okay, I think it is clear to all my students, but you have to do practice for it, as it is not easy to understand without practicing it, because practice makes a man perfect. So proceed to next. This is again, I have included a slide for your more clear concept, that the red lines here shows the incident rays, the blue lines shows the reflected rays. Okay, and next slide. Now this slide is very important. If you see here in diagram A, I have placed eye above and object down. Now it should be clear to you, if in any question these rays are not visible to you, you have to draw these reflected rays. Only object is there and eye is here. Then you will continue the process, take the perpendicular distance from the bottom, from the top, draw the shape, draw the rays from the top to bottom towards the eye. The red arrow shows the reflected rays. There you got the point of incidences, and from point of incidences you will draw the incident rays towards the mirror. And if the eye is placed down and the object is like this, again you will repeat the steps. Always remember, your main step for the construction is, after drawing the perpendicular equal distance behind the mirror also, from the image there will be rays comes and converges to the eye, and they will give you point of incidences, and then you will join from the object top and bottom to these point of incidences, and your image will be complete. So it's a very good diagram. You must include this diagram in your neat copies. I want it to be done and drawn by all of you pretty neat. Okay, now we will move towards the examples, as examples are the important part of the lecture. Without understanding the examples, you will not be able to solve any question. So in the first example, the diagram shows a ray of light being reflected by a plane mirror MN. There is a mirror you can see in the diagram, that is MN. Which one of the following statement is correct here? You can see that LP is the incident ray, this PR is the reflected ray, QP is the normal, X is the angle of incidence, Y is the angle of reflection. Now you have to tell LP is incident ray, PR is reflected ray, okay, and X is the angle of reflection. No, X is the angle of incidence, so it's wrong. Next, LP is the reflected ray. No, LP is the incident ray. So this statement is again wrong, and X is the angle of incidence, right? While Baki say, yeah, but LP is not reflected ray, it's incident. So this is also wrong. C, LP is incident ray, right? X is the angle of incidence, right? Y is the angle of reflection, it's right. Last one, PQ is the normal. Sorry, it's also right. X is equal to Y, it's also right. And PR is the incident ray. No, PR is the reflected ray. So our answer is C. Clear? Next, reflection by the plane mirror. You have to note it in all these diagrams that normal always perpendicular to the mirror, angle of incidence, angle of reflection. Again, for your recap, I have added this slide. Now example 2. The diagram shows a ray of light reflected in a plane mirror. What is the angle of reflection? Now this is very good example. This type of examples are also included in your book. So consult your book also, solve all those examples. They are very, very important for clearing your concept. So how will you will calculate the angle of reflection? These calculations, see the diagram. This is incident ray, this is normal, this is the reflected ray. And they have given you the angle between the mirror and the incident ray. If this angle is 40, this whole angle from the mirror to the normal is 90. So 90 minus 40, angle is 50. So if it is 50, then angle of reflection is equal to angle of incidence, and angle of incidence is equal to 50. Is it clear, girls? I hope so it's clear. Next, a ray of light is reflected from a plane mirror as shown in diagram below. What is the angle of incidence? Again, you have to draw a normal here. After drawing a normal, you have to subtract this 10-degree angle from the 90-degree. Of course, your answer will be 80. Now, the second last part of our lesson, that how you can verify the law of reflection. Now this is very important part of our lesson. I have also included a video in your resource. See all those videos very carefully, girls, please, because they will make your concepts more clear. Okay, now let's start it. As we know, the laws of reflection are the incident ray, reflected ray, and normal at the point of incidence all lie in the same plane. The second is the angle of incidence and angle of reflection are equal. Now for its verification or the experiment, you need a wooden drawing board and fix a white sheet of paper on it. When you fix a white sheet of paper on it, in the middle of the paper, draw a straight line KK. Now you have to draw this diagram also in your notebook. Make a straight line, show the back of the mirror in drawing these small lines. There's a smooth surface ahead, and how you will do it, after drawing a line, you will place a mirror strip, a small mirror strip in a rectangular form will be placed on this line. Okay, now after that you will put two pins P and Q in a straight line, but the distance between these two pins should be more than 5 centimeters. This is a very, very, very important instruction I am giving you. This instruction is also used in ATP solving papers, and it is a main marking scheme of many questions, that the distance between the two pins should be more than 5 centimeters. Okay, so fix two steel pins P and Q on a straight line AB at least 10 centimeters apart. Okay, 10 centimeters apart means the distance between these two pins should be more than 5, and a few distance from also from the point B, that is the point of incidence. Okay, now after that, as you have placed here, this B is a mirror strip. As you placed the mirror here, you will see its image and observe it from your eye, where you see the image of those pins in a straight line. Now again place two more steel pins Q dash and P dash, such that all the pins are in same straight line. Now after they are in straight lines and you have placed the pins in the right distance, the distance between these two pins should also be more than 5 centimeters. You will remove the pins and draw small circles around these pin pricks, where the pin will leave a mark. At that, around that point, you will draw the circles, small circles, not very big. Your pencil should be very sharp. These are all instructions you have to remember. Your pencil should be very sharp for this experiment. After that, you will draw the straight lines PQ dash touching the mirror line, and P dash Q dash again proceed it where they meet. Then you will draw the normal N at an angle of 90 degree. Then by the help of protractor, you will measure these angle of incidence and angle of reflection, and you will find that angle of incidence will be equal to angle of reflection. For example, if the angle of incidence is 30, it will also be, reflection will also be 30. So this experiment proves the two laws. Number one, the incident ray, the reflected ray, and normal all lie in the same plane. Okay. Okay, now see in this diagram, The reflected ray and the angle, the incident ray, this is the incident ray, you have to draw an arrow on it. After that, this is the reflected ray, you have to draw an arrow, and no arrow on the normal. This is the reflecting surface, and it will prove both laws. The incident ray reflected in normal all lie in the same plane. Second one is angle of incidence is equal to angle of reflection. Next example, very important. A person stands 2 meters in front of the mirror as shown. How far from the person is her image? Now for that, you have to concentrate on the diagram. It stands 2 meters in front of the mirror. Okay, how far from the person is her image? You should recall the properties of the image in the plane mirror. If the object is at this 2 meter distance, now behind the mirror, the object is also at a distance of 2 meters. Now from the image, you have to find the person distance from the image. So 2 meters from the mirror and 2 meters of the image. 2 plus 2, the answer will be 4 meters. It's very easy, but you have to understand. The diagram shows two divergent rays of light from an object O being reflected from a plane mirror. At which position will the image be formed? This is a very important sorry. This is a very important MCQ, students, because you have to find which position will the image be formed. For that, you recall again, you always have to recall the properties of the image formation in a plane mirror. The object distance and image distance, they will be equal. Now measure this distance and draw a perpendicular line, the point which it intersects, and from point it will hit definitely point B. It will never hit point C or point D. Okay, so point B is the answer again by the formation of image line perpendicular to the mirror. This is a simple diagram which shows a very important fact, that image formed by the plane mirror, if the object is placed in the direction of normal, not at any angle to the mirror, okay, then the image will also form at normal. There will be, of course, no reflected ray, because if you draw a perpendicular line here and here, okay, it is in the direction of normal. Okay, this simple image of a candle. Now we will give a quick recap what we have done up to now. We have discussed various cases of rays, regular reflection and diffuse reflection. The regular reflection is on the plane mirror surface where the reflected rays are parallel to each other. The diffuse reflection, the reflected rays are spreading, they are diffuse, they are not going to give any image, and they're also not parallel. The other two general phenomena you should have an idea about it, that if the rays are not reflected, there are no coming out of the rays. It means it's a black surface. Now black color is the best absorber, you know. Then it will absorb in this process is known as absorption. But if it's a transparent material, if any surface is a transparent material, from transparent materials the light rays can pass easily. Okay, so this process is known as transmission. Okay, next. So we have discussed in the start of our lecture about the two types of reflection, the regular from a smooth surface, the irregular from the irregular surface. Now I have added this slide to just show you in reality the image formation in a plane mirror in a regular reflection. You can see in here in the diagram that this is the coming ray, this is the reflected ray. Now it's not a plane surface, it's a rough surface. You can see it's not plain and smooth, it's rough. So rough surface, no reflected ray here, as we have seen in this. There's a reflected ray. There is no reflected ray. Okay, is the diagram clear to all of you? So this is the case of diffuse reflection when the rays are going to spread. Now, this is a simple application of reflection of light. Periscope. Periscopes are used in submarines so that people below the water surface can see what is happening above. Maybe you have made those periscopes or studied it earlier in the previous classes. I hope so. But if not, it should be clear to you that two plane mirror strips are used in it. It's a long straight tube in which two mirror strips are used by placing them at an angle of 45 degrees. when the incident ray is come on it, okay, the angle of incidence is equal to angle of reflection. You will draw a normal. When it will reflect, it will become an incident ray for the second mirror, and then will it reflect and give a view to the eye. This is a very important application. Now another question. There's an old past paper. This is very important one. Which of the following correctly describes the image formed in a plane mirror when compared to the object? Now you remember again the properties of image formation in a plane mirror. The image is always virtual and same size. So A option is incorrect, B is right, C is also incorrect, and D is also incorrect. An object O is placed in front of a plane mirror. A viewer looks into the mirror as shown in diagram. In which position is the image of O formed? The image of O formed, of course, when you draw a line perpendicular of having equal distance, it will meet at point B. So B is the answer. Okay? Not A, C, or D. C and D both are on mirror, they can be. So B is the image position. The diagram shows a ray of light being reflected by a plane mirror, MN. Which of the following statement is completely correct? We have done it earlier, so girls? Yes. The diagram below shows the position I of the image formed by the plane mirror of an object O. Now you can see the object is there. You have to continue two rays drawing leaving O to show how they would be reflected in the mirror. This is drawn for you for your understanding. From O you will draw a perpendicular equal distance, and you will draw I from I. You will two rays behind the mirror. You will draw the dotted lines in front of the mirror, straight rays. Okay, there are two marks of it. One mark for correct distance from the mirror. The second mark for drawing the correct incident and reflected rays. Second part is I is a virtual image. Explain the meaning of this. Virtual, we have discussed above that the virtual image is the image which cannot be projected on the screen, okay, and it can be formed by the converging of the rays. Okay, thank you so much, girls. I hope so that you have understood the topic well. I have included also the questions. Now, your assignment is one more assignment I'm giving you, except that written assignment yet. You have to solve all these examples and diagrams on your notebook as well as all the diagrams including in this topic. You have to draw, that is of regular reflection, diffuse reflection, the image formed by a pointed object, the image formed by the extended object. Hope so you have understood well. Take care of yourself. Allah Hafiz.